Our next speaker is Carolyn Ellinger from Kodak, and they're going to be speaking about flexible heaters manufactured using high-resolution flexography. Go ahead.
All right, thank you. So all of this work was generated by either my team at Kodak or some students at RIT, and I will try to point out acknowledgments as I walk through the slides. And so quick agenda, I'm going to talk a little bit about what we do at Kodak in the arena of printed electronics, kind of level set us all in terms of what the heater fundamentals are. I know they're very ubiquitous and a very simple device, but just want to lay out what we're trying to achieve, and go through some examples of where custom heaters can be beneficial over COTS heaters and how Kodak works with its customers to provide optimized solutions. And so just in terms of what's inside my organization, we partner with customers three ways. And at the heart of it all, we are a service provider. We are contract manufacturers. So if you look at our manufacturing workflow, it goes through design, through piece part delivery. And so we can kind of break into that manufacturing flow at any point to deliver value to our customers. So we practice printed electronics through flexography. And we know that we cannot meet the world's needs for printed electronics with the volume of our facility. And so we enable others to do high-resolution flexography in their facility by providing a tool set to generate plates, right? So we can sell plates that have been patterned. We can sell you the computer-to-plate equipment to generate plates in your own facility, to get to photopolymer plates at 2-micron resolution, so 12,800 dpi. And so that's one way that we provide value to our customers, and that's what we use to the next step of our manufacturing process, which is actually printing. And so we have two ways that we can use our printing assets. We can do what we call direct print, which everyone else in the industry would just call printed electronics. And what we mean by direct print is exactly what you would think. You take a functional ink, you put it down, you cure it, and at the end of the day, you have a functional product out the end of your printer, right? So it is a printed electronic element. And we make those products for customers. You can make heaters in that way, where you're putting in conductive materials into your printing press, you're printing an appropriate pattern, and at the end of the day, you have that functional heater at the end. A lot of what we've done historically and what we continue to do today, and what I'll be sharing a little bit more within the following slides, is taking that printed product and pushing it through to electrolysis copper plating. So instead of printing an ink that is inherently conductive, we will print a catalyst. It's a low volume printing process, so you can get very high fidelity because there's not a lot of ink that's going to spread. So you get really good XY fidelity of a printed catalyst, then you put it into a plating bath of copper, and so you get the quality copper from the electrolysis plating. You can control the electrical performance both by that XY pattern as well as by the thickness of copper you choose to deposit. And so, in that way we can make transparent products. If we were going to look at bulk copper, that's not necessarily the most cost-effective way to do it. So we leverage that manufacturing line for things that really take advantage of our high resolution. So if you don't need high resolution, we tend to fall into the direct print mode of operation. If you really need that high resolution, high performance electronics, low sheet resistance, we push it through to electrolysis copper plating. And then everything after that is finishing. Converting, right? So we have a full roll-to-roll tester. We can test our products in roll form. We can do electrical, optical testing. We can do some converting to die cut products. We add liner for protection. If we're talking about antenna, which we're not today, we can do end-of-line RF test as well for our RF customers, and full-scale disposition. And so that's kind of what we do in my business. I'm going to talk a little bit about how we serve customers in the heating space. And so before I get there, just a little bit more about what we mean by copper microwires. Oftentimes people call them metal mesh, right? So we can, because we are doing flexography, we can rapidly design and turn out different mesh patterns. So we're not fixed at a given pitch and line width. We can design the pitch and line width for any customer, for any application. So what you see here is kind of the feature set on the flexographic plate on the lower left side. And then in the table, you see different actual optical micrographs of what the copper wire meshes look like. And so you can choose what your transparency is, what your electrical resistance is based on that design that you use. And so that gives you ultimate design freedom for electrical versus transmission